Good day, boys. Good day, girls. How are you? Hope you are well. Hope you are safe. For this afternoon, we start with our math lesson again. So carry on with our measurements. So we started the measurement yesterday. So we'll carry on with it also today. All right. So before I continue, my name again is Sabdo Jafaru, and then our topic this afternoon is measurement. All right. So at the end of today's topic, you should understand the different types of polyhedrons, which we looked at yesterday, but we're going to carry on with it today. And then must understand how to derive the 2D objects, the formulas, and to solve problems related to 2D objects. Okay. Right. We'll start with area of polygons. Area of polygons. So we talk about square. So of course we know a square is a 2D shape with equal sides. In a sphere, all sides are equal. And then when we talk about the area of a square is side squared, side times side is the area for a square. Okay. And then for a rectangle, this is what this a rectangle, this is how a rectangle will look like. So you have the breadth and then you have the length or the height. To find the area, of a square, to find the area of a rectangle, then we say it's length times the breadth, or the height times the breadth, or the breadth times the height. So that will give us the area for a rectangle. Okay. And then for a triangle, for a triangle like this, we say the area of a triangle is half times base times the perpendicular height. So the base and the height must be perpendicular. For a triangle, we say the area of a triangle is half times base times the perpendicular height. Okay, half times base times the perpendicular height is the area for a triangle. Okay, so note that the height and the base must be perpendicular to each other. Okay, so go to the next one. So talk about a trapezium. This is how a trapezium looks like. The trapezium is that 2D shape with a pair of parallel sides. So A and B are the two parallel sides. Okay, and then we're saying to find the area for a trapezium. The formula for finding the area of trapezium is half bracket A plus B times H. Okay, so the area for a trapezium again is half A plus B bracket times H, or simply put it, half times the sum of the parallel sides. The sum of the parallel sides multiplied by height is the formula for finding area for a trapezium. So we need to learn all these formulas so that we can have a good grasp of our mathematics. All right. Now the next shape is the parallelogram. So a parallelogram is a 2D shape with two pairs of parallel sides. So opposite sides are parallel in a parallelogram. In a parallelogram, opposite sides are parallel. This side is parallel to this side is parallel to this. So you see opposite sides are parallel in a parallelogram. Okay, and then to find area for a parallelogram, we see what? The base multiplied by the height. Remember, the height must be perpendicular. The height must be perpendicular. Okay, so the formula for finding the area of a parallelogram is height times the base, whereby the base and the height must be perpendicular. Okay, and then the last one is circle. So circle would be the circle with the center R, and the radius R. So with radius R, to find the area for a circle, the formula for find the area of a circle is pi r squared. Pi r squared, where r is our radius, and then in case we want to find the circumference of a circle, the formula for finding the circumference of the circle is 2 pi r. 2 pi r. The formula for finding the circumference, while the area is pi r squared. All right. So that is the formula. So we need to have a good grip of these formulas, memorize them and apply them, and then we can have a good grip of our mathematics. Okay. Now let's see some example. Example 1. ABC is a parallelogram with DC 15 centimeters, H 8 centimeters, and FB 9 centimeters. Okay. ABC is a parallelogram. Also, you can see it's a parallelogram. Okay. It's in the parallelogram because this AB parallel to DC and AD parallel BC. Now, DC is given as 15 centimeter. DC is 15 centimeter. Then height H, the perpendicular height H, is given as 8 centimeters. And BF is 9 centimeters. BF is given as 9 centimeters. Okay, the question now is calculate the area of triangle ABC. Calculate the area of parallelogram ABC, because ABC is a parallelogram. So what is the area of parallelogram ABC? Okay. The area of parallelogram ABC will be, as we just said, is what? The height times the base, where the height and the base has to be perpendicular. So here we're saying the height here is perpendicular to the base. So the height is given as 8, and then the base is given as 15. So to find the area of this parallelogram, we use a formula: height times the perpendicular base, or base times the perpendicular height. So basically we have what? 8 times 15. Will give us our answer in centimeters squared. Okay, so that's what the area of parallelogram ABC. Multiply 8 by 15. Okay, all right, and then we need to find the perimeter ABCD. Find the perimeter ABCD. How do you find the perimeter ABCD? To find the perimeter ABCD, how do you find the perimeter ABCD? So perimeter implies we add all the sides. When you find the perimeter, perimeter is the addition of all the external sides. In perimeter, you need to add all your external sides. Okay, so you need to find all our external sides and add them to find the perimeter of ABCD. Okay, now here is what we have BF as 9 centimeters. Okay, BF is 9 centimeters, and then DC is 15 centimeters. So because DC is 15 centimeters, that means AB is also 15 centimeters, because it's a parallelogram. Opposite sides are parallel and they are equal. For a parallelogram, opposite sides they are parallel and equal. So because it's a parallelogram, AB is parallel to DC, and AB is also equals to DC. So obviously AB is what, 15 centimeters, but our BF is 9. So we need to actually find BC. So we need to find BC. So how do you find BC? How do you find its length? BC. Okay, to find them BC, what do? We can't use this 9 to find this 9 is not for length BC. 9 centimeters is for BF. To find length BC, what do? We can look properly. Looking at the parallelogram properly, if you consider triangle ACD now, or better still, let's consider triangle. Let's see triangle ADC. Okay, so let's look at triangle. Let's look at triangle ABF. So with ABF, this BF is 9 centimeters, and then we know that AB is 15 centimeters. So let's find our side AF. Okay, so to find side AF, so let's see. So we think for the first question, to find the area of a parallelogram ABC, the formula is base area times height. So our area of the base multiplied by height. So 15 times 8 to give us 120 centimeters squared. And then for the second one, to find the perimeter of ABC, to find perimeter is to add all our two sides. To add all the two sides. Okay, so adding the two sides is basically saying what? 2DC plus 2BC. So 2DC plus 2DC plus 2BC, because DC and AB are equal, and then AS and BC and AD are as well, they are equal. So to find the perimeter, we can simply say what? 2DC plus 2BC. And then to do that, so we need to consider triangle ABF, and then try to find our value of AF. We need to consider triangle ABF and try to find our side AF, because we already had our AB as 15. So using a Pythagoras theorem, using our theorem of Pythagoras, we're trying to find our side AF. Okay, we're trying to find our side AF. And once our side AF is found, we can use our side AF to find our side AD. Okay, use our side AF to find our side, to find the side AD. Okay, which is equals to BC. So now our AF squared equals to AB squared minus BF squared. According to Pythagoras, if you are finding the length of the side, then you say hypotenuse, the square of the hypotenuse minus the square of the other side. So that will be 15 squared minus 9 squared, and that will give us 144. Okay, square root of 144 is 12. That means our AF is 12. So because our AF is 12, so area of ABC is equals to area of BC plus times area of AF. So from there, you can find our length of BC to be 10 centimeters. Because our AF is 12 centimeters, because now we have our AF as 12 centimeters. So we can, all what we need to find is to find our length BC, which is equal to our length AD. Okay, so now we need to find height H first. So getting our height H, how to get our height H is to use Pythagoras, consider triangle ABF. So AB is 15, AF is 9. So AB is the hypotenuse, 9 is the A side, opposite side. So with that, I can find our adjacent. So by adjacent, we say adjacent squared equals to hypotenuse squared minus the opposite squared. So 15 squared minus 9 squared, and that will give us 12. 144, and then that gives us the square root of 144 is 12. So our AF is 12 centimeters. So because our AF is 12 centimeters now, so we can look at this parallelogram in the other way. We can calculate the area. We can try to find the length BC, because we have the area of the whole parallelogram. So we can consider this as our vertical height, and this is our base. So, and then we can use the formula of our area that we had to find side BC. And once BC is found, with the BC, we'll then be able to find the perimeter of the whole parallelogram. Okay. So you're saying the first thing to do is to calculate our AF. Once our AF is given, then we consider ABC as consider the area of ABC as 120. And with the area, we already said area is what? The base times the perpendicular height. The base times the perpendicular height. So if you look at here, if you look at the parallelogram properly, this is the height that is perpendicular to the base. You can consider this as our height and this our base. So with that, you can find our actual base, BC. So because we had the area as what? 120. The first question asks us to find the area, which got as 120. So we are the area as 120. So the area of the parallelogram is 120. So with the area, you can find the side BC. So area equals to BC times AF. So BC equals to 120 divided by 12. BC equals to 10. So once BC is 10, and then from there, you can find the perimeter of ABC by saying 2 times 15 plus 2 times 10. 2 times 15 is 25. 2 times 15 is 30. And then 2 times 10 is 20. And add together get 50. That's about the perimeter for parallelogram ABCD. Okay. Hope you do understand that. Right. We look at example 2. Buyo and Bannerless are having a competition to see who can build the best kite. Buyo and Bannerless are having a competition to see who can build the best kite using balsa wood, a light wood, and a paper. Buyo decides to make his kite with one diagonal 1 meter long and the other diagonal 60 centimeter long. The intersection of the two diagonals cut the longer diagonal in the ratio 1:3. Bannerless also used diagonals of length 60 centimeters and 1 meter, just like Buyo. Okay, but he designs in his kite to be a rhombus shaped. He made his kite a rhombus shaped. Now, question now says, draw a sketch of Buyo's kite and write down all the known measurements. Okay, let's look at it again. Buyo and Bannerless are having a competition to see who can build the best kite using balsa wood. Balsa wood is a light wood and a paper. Okay. Buyo decides to make his kite with one diagonal 1 meter. So the first diagonal is 1 meter and the other diagonal will be 60 centimeters. That means the longer diagonal. Remember, in the kite, we have two diagonals. So we have a longer and a short one, a longer one and a shorter one. A long one and a short one. Okay. So now the intersection of the two diagonals cuts the longer diagonal in the ratio 1:3. 1:3. Right. Now Bannerless also used diagonal of length 60 centimeters and 1 meter, but he designs his kite in a rhombus shape. Now to draw the shape of Buyo's kite, so we're going to draw the kite, but the diagonals now, the shorter diagonal will be 60, and then the other diagonal will be 60 centimeters. The other diagonal will be on 1 meter, which is 100 centimeters. Okay, so our answer then looks like this. So we're going to have a kite that looks like this. We're going to have a kite in this shape. So the shorter diagonal is 60 centimeters, and then the longer diagonal will be 100 centimeters, 1 meter. But the other diagonal bisects the shorter diagonal bisects the longer one in the ratio 1:3. Ratio 1:3. That means what? Here will be 25, because if we do the ratio, 1 plus 3 is 4. So that means the whole length will be divided into 4 portions. So that means the bisection will be just 1 out of 4 portions, which is what? 25 centimeters out of 100. So our diagonal, this length here will be 25, this length will be 75, all giving us what? 100 centimeters for the longer diagonal. And then the shorter diagonal, you have 60, which is what? Bisected. So here is 30, here is 30. So these are the dimensions. This will be the shape of the kite that Buyo will be having. Here being 25, here being 75, here being 30, here being 30. Okay. Right. The next question: determine how much balsa wood Buyo will need to build the outside frame of the kite. Determine how much balsa wood Buyo will need to build the outside frame of the kite. So outside frame of the kite means what? Means the perimeter of the kite. And then if they give you answer correct to the nearest centimeter. Because you have to give your answer into the nearest centimeter, is an indication that you need to find a length, a sort of length. So don't make a mistake of calculating the area. Again, the question says determine how much balsa wood Buyo will need to build. Determine how much balsa wood will Buyo need to build the outside frame of the kite. Outside frame of the kite. So outside frame implies what? A frame that will go all around the outside, which in this case we're talking about the perimeter. So basically you need to find the perimeter of the kite. Okay, so to find the perimeter of the kite, you need to find all the length, all the outside lengths. You need to find length AB, you need to find length BC, you need to find length CD, and you need to find length AD and plus all our lengths together. So how do you find length AB? With Pythagoras, we find length AB. And remember, in the kite, adjacent sides are equal. So AD is equals to AB. AD is equals to AB. So we need to find, so which one of the right angle triangle can find length AB, which is equals to length AD. So use Pythagoras and find your length AB. So length AB is equals to AB squared is equals to 25 squared plus 30 squared. And then it will be square root of 25 squared plus 30 squared. to get our AB. Also, so AB here will also be equals to AD here. So to find our BC, we use Pythagoras the same as well. We use Pythagoras as well. So to use Pythagoras as well to find length BC, what do we do? We say what BC squared, BC squared equals to 30 squared plus what 75 squared. BC squared equals to 30 squared plus 75 squared. And then if you do 30 squared plus 75 squared, then BC will be the square root of 30 squared plus 75 squared. That will give you your BC. And obviously your BC and your CD are equal. Adjacent sides are equal in a kite. BC is equals to CD, AB equals to AD. So with Pythagoras, we're trying to find our BC, which is also equals to CD. And then we can find the perimeter of the frame, of the perimeter of the wooden frame that needs to go around the kite. Okay. So saying determine how much balsa wood we need to build outside the frame of the kite. So we need to find the perimeter. So we need to find AD. Say AD equals to AB. Okay, adjacent sides are equal in a kite. So we need to find our length AD. So 30 squared plus 25 squared. Find the square root of that. That'll give you 39. So AD is 39. So AD is 39. AD is 39. Therefore, AB is also 39. So to find BC, you say what? 30 squared plus 75 squared. Then you find that square root. Okay, 30 squared plus 75 squared. Find the square root to give you 81. That means BC is 81. Also, DC is 81. So from there, you cannot find the perimeter of the kite. So we can say 2 into 81 plus 39, and that will give us 240. Or you can say 2 times 39 plus 2 times 81. So if you do 2 times 39 plus 2 times 81, it gives us what? 240. Now give us the perimeter of the frame. Okay. Question C says, calculate how much paper will you need to cover the frame of the kite. How much paper will you need to cover the frame of the kite? So how much paper will you need to cover the frame of the kite? So what we do, how do we find the area? Then in this case, we find the area. How much paper will you need to cover the frame of the kite? So to find the area for a kite, this is the kite here. So this here is what is referred to as the frame of the kite. So how much area will you need for the frame of the kite? So basically need to find the area of the kite. To find the area of the kite, the formula is what? Diagonal 1 multiplied by diagonal 2. Multiply the two diagonals. So the diagonal 1 multiplied by the diagonal 2. Okay. So diagonal 1 is what? 60 centimeters. Diagonal 2 is 100 centimeters. Multiply that together. That will give you 6,000 centimeters squared, which is equal to 0.6 meters squared. Okay. So the diagonal is 6 meters squared. Again, calculate how much paper will you need to cover the frame of the kite. So this is different from the first question. The first question says determine how much balsa wood, that the paper we will need to build the outside frame. So outside frame, we mean what? The perimeter. Outside frame, we mean the perimeter. But this one here saying calculate how much paper you will need to cover the frame of the kite. So that would imply the area. And the area of the kite is what? The product of the two diagonals. The product of the two diagonals. So the first diagonal is 60. The first diagonal is 60 centimeters, and the other diagonal is 100 centimeters. So we multiply that to give us the area for a kite. Okay. Now we go to the next one. Now draw a sketch of Bannerless kite and write down all the known measurements. Draw a sketch of Bannerless kite and write down all the known measurements. So what about Bannerless kite? Let's see with Bannerless kite. It's saying Bannerless also uses diagonals of length 60 centimeters and 1 meters. He also uses diagonals of what 60 centimeters and 1 meters, just like Buyo. But he designs his kites to be rhombus shaped. So rhombus shaped, we all know a rhombus. A rhombus is basically a sort of square that is bending, that is not standing firm. It is square. A rhombus is a square that is bent, that is tilted, that is not standing properly. So basically, in a rhombus, all these sides are equal, just like a square. All the sides are equal, and then the diagonals are the length of diagonals are equal, and then they bisect each other. They bisect each other at 90 degrees. So in rhombus, diagonal bisect each other at 90 degrees. That is one. And then all the sides of a rhombus are also equal. And also the diagonals bisect corner angles. Unlike kite, in a kite, only adjacent sides are equal. But in a rhombus, all the sides are equal. Okay, and then only one diagonal is bisected in a kite. But in rhombus, both diagonals are bisected. Okay, so again, Bannerless also uses diagonal of length 60 centimeters and 1 meter. So diagonals is also 60 centimeters and 1 meter. 1 meter or 100 centimeters. But he makes a different design. Instead of making it form of kite, he makes his kite to be a rhombus shaped. Now the question now is draw a sketch of Bannerless kite and write down all the known measurements. So if you're going to see Bannerless kite, it's going to be a form of rhombus. So you're going to take this shape. This kite will look like this. So because it has two diagonals, and then remember saying in a rhombus, both diagonals bisect each other. So they both diagonals bisect each other. So both diagonals are bisected. That means we're going to have here will be what 50. Here from here to here is also what 50, because the whole length of this diagonal is 100, and here you're going to have it as 30. You're going to have it as 30. So this kite will have this shape. This will be the shape of Bannerless kite. Okay. Now the next question: determine how much wood and paper Bannerless will need for his kite. How much wood and paper will Bannerless need for his kite? So now, what does that mean? How much wood and paper? So how much wood will you need to make the kite? So that will be about what the area of the kite. That's about the area of the kite. So the area of the kite, or basically the area of the rhombus, is what? Also the product of what? The product of the diagonals. The product of the diagonals. Okay. So to find the area of the paper that Bannerless will need is to find the area of the diagonals. Okay, so the area of diagonals will be what? 60 centimeters multiplied by 100 centimeters. And that will give us what? And that will give us 6,000 centimeters, which is also equals to 0.1 meter squared. How do you convert this one to 0.6 meters squared? We divide it by 10,000. To convert from centimeter squared to meter squared, we divide by 10,000. Remember, 100 centimeter is 1 meter. So to convert from centimeter to meter, we divide by 100. But to convert from centimeter squared to meter squared, we divide by 100 squared. 100 squared is what? 10,000. So we divide 6,000 by 10,000, we give you 0.6 meter squared. So now talking about the perimeter now. So to find the perimeter, determine how much wood and paper Bannerless will need to make we need for each kite. So to find the area is what? The product of the two diagonals, which is diagonal 60 centimeters multiplied by diagonal 100 centimeters, and that gives us 6,000 centimeters, which is 0.6 meters. Talking about the perimeter now, we need to find the length of each side. We need to find the length of each side of we already said for a rhombus, all the sides are equal, just like that of a square, right? So we need to find the length of one side and then multiply by 4. How do you find the length of one side? You can simply use our Pythagoras, saying 50 squared plus 30 squared, the square root of 50 squared plus 30 squared will give us what? AD. So once we have AD, so we can multiply by 4 to give us the perimeter of the whole kite. Okay. Right. Now let's go to F. Now F says compare the two designs and comment on the similarity and differences. Which do you think is the best design? Motivates to answer. So we can see now both kites have the same area. The area of Bujo's kite is 0.6 meters squared. As we just calculate, Bannerless is also what? 0.6 meters squared. But when you look at but they have different designs. So, but the perimeter is different. For Bannerless is 233.2 centimeters. But for Bujo, its perimeter is 240 centimeters. So 240 centimeters is that of Bujo, and the Bannerless is 233 centimeters. So the designs are different, but the area remains the same. And then the design is also the same. Okay, so right. So we can say basically that Bujo use what? Use more balsa wood. Bujo use more balsa wood, okay, because of its more perimeter. Okay. So let's go ahead with that. Let's see another question. It's saying another question, example 3. O is the center of a big semicircle with radius 10 units. We have a big semicircle here with radius 10 units. So radius is 10 units here. Two smaller circles are inscribed into the bigger one. So here you have got two smaller circles inscribed into the bigger one as shown in the diagram. Okay, calculate the following in terms of pi. Calculate the following in terms of pi. The area of the shaded figure. Find the area of the shaded figure. How do you find the area of the shaded figure? Then we need to find what? Find the area of the shaded figure. We need to find the area of the two. We need to subtract the area of the two smaller semicircles from the big semicircle. So find the area of to calculate the area of the shaded part, which means the gray part, the area here. What we need to do is to find the area of the two small semicircles and then subtract it from the area of the big one, and then that'll give us the area of the shaded part. Okay, so how do you go about this? And then must leave your answer in terms of pi. Remember, area for a circle is pi r squared. For a full circle, the area is pi r squared. So for a half circle, for a semicircle, it's going to be half pi r squared. So for the big circle, for the big semicircle, so you're going to say half times pi r. Our radius for the big circle is 10. It will be half times pi 10 squared. And 10 squared is 100, that will be, and half of 100 is 50. That will be what? 50 what? Pi. Okay, we'll have it at 50 pi. And then you need to calculate the area of the small semicircles. So find the area of the first one. What you're going to have for the first one, what will be the diameter for, what will be the radius for each of the small one? What will be the radius for each of the small one? If the whole of this is if the radius here is 10, that means from here to here is 10, from here to here will be what? 5. From here to here is 10, and then from here to here will be 5. And here is also a 5. So basically the radius of the small circle, the white part will be 5. Okay, because the radius of the big circle is 10, that means from the center to the circumference is 10. So because radius is also half of diameter, so this radius of the big circle is the diameter for the small circle, small semicircle. So therefore, the radius of the small semicircle will be half of 10, which is what? 5. So with that, you can find the area of the small semicircle multiplied by 2 and then subtract it from the area of the big semicircle. Okay. Right. So we're saying area equals to half times pi 10 squared for the big semicircle. And then 10 squared is 100. Half of 100 is 50. We're going to have 50 pi. And then for the small circle, for the small semicircle, The radius will be 5. Radius will be 5. So 5 squared is 25. So be 5 squared is 25. So you're saying what? Half times 5 squared, because it's half pi r squared is the area for one semicircle. So you are multiplying by 2 because there are 2 semicircles. So the 2 cancel out the half, and you are left with what? Pi 5 squared. The 2 outside of the bracket cancel the 2 here. So you're having what? 5. I mean 5 squared, which is 25. 25 what? Pi. So pi will be this will give us 25 pi, which we put together 50 pi minus 25 pi give us 25 pi. So basically the area of the shaded part is 25 pi. The area of the shaded part is 25 pi. Okay. And then the next one, the perimeter of the enclosing, the perimeter enclosing the shaded part. What part? What is the perimeter enclosing the shaded part? So this there is the shaded part. What is the perimeter enclosing it? So in that case, we need to find what the perimeter of this enclosing it means, what that is bounding it. So we need to find the length of this perimeter for the small circle, and find the length of this other perimeter for the other small circle, and then the length of this circumference, the circumference of the small circle here, the circumference of this circumference here, plus this circumference here, then plus what? The half circumference of what? Of the big semicircle. So if you do that, so remember our circumference is what? 2 pi r. 2 pi r is our formula for circumference for a circle. Again, circumference of a circle is 2 pi r. So now, because talking about what half, about a semicircle now going to be half 2 pi r. So for the big semicircle, going to be half 2 pi r. Remember the r for the big semicircle is 10. So half cancels the 2 by half cancels the 2 here. You left with 10 pi. So the perimeter you brought 10 pi. And then for the other one, for the other 2 small circle, so for the other 2 small circle is going to be 2 pi times what? 5. Because there are supposed to be half times what? 2 pi r. Half times 2 pi r. Each one is what? Each one, the circumference of each small one is half of 2 pi r. So half of 2 pi r, 2 pi r is the formula for a full circumference. Because this one is half circumference is what? Half 2 pi r. So half 2 pi r means what? Pi r. So that means the circumference for here is what? Pi r. The circumference for here is also what? Pi r. So add pi r to pi r will give you 2 pi r. That means the circumference of the 2 semicircles is what? 2 pi r. And then remember their radius is what? 5. So we put that together. So 2 pi times what? 5. And that gives us 10 pi. So add that together, that gives us 20 pi. Okay, so 20 pi will be the perimeter enclosing the shaded area. The perimeter enclosing the shaded area. Get that? The perimeter, and remember that this other length here will not be added. So the perimeter enclosing the shaded area is the gray part here. So it's referring to only this half circumference, and then the shaded area is bounded by this half circumference and this half circumference of the smaller 2 semicircles. So that is what we add together. That is what is bounding the shaded area. So that's what we need to add together. I do hope you understand that. Okay. Right. Now let's see this quickly. Example 4. Karen engineering textbook is 30 centimeter long. It's 30 centimeter long. Karen textbook is 30 centimeter long and 20 centimeter wide. Karen engineering textbook is 30 centimeter long and 20 centimeter wide. She noticed that the dimension of her desk are in the same proportion as the dimension of her textbook. If the desk is 90 centimeter wide, calculate the area of the top of the textbook. Karen engineering textbook is 30 centimeter long and 20 centimeter wide. She noticed that the dimension of her desk are in the same proportion as the dimension of her textbook. If the desk is 90 centimeter wide, If her desk is 90 centimeters wide, so what's the area of the top of the desk? So now look at the width of the desk and then the width of the textbook. So to know what proportion are they? To know what proportion are they? So with that, we can be able to, now we have the width of the text, we have to calculate the area of the top of the desk. So to find the area of the top of the desk, we need to find the width and the length. So the width we have as 90, all we need to find is the length. So to get the length, you need to know the proportion. Now, so what is the proportion? The width of the textbook was what? 20, and the width of the table was 90. So 90 divided by 20, whatever that gives us, we multiply that with our 30 to give us the length of the desk. And with the length of the desk, you can now find the area. Okay. Okay. Now we're saying ratio equals to the table width over the book width. So 90 over 20 will give us 4.5. That means this is the proportion by which the table and the textbook is adjusted. That is their relationship. That's how they are connected. So from there now, the length of the table now will now be 30 multiplied by 4.5. That will be 135. And from there, you can find the area of the table. So thank you. We're going to end our class here today, and then we'll carry on from there tomorrow with our measurement class. Our time is not by our side. So thank you for listening and enjoy the rest of your day.